Oh dear, this is where I left you on my last video. Why was my Tesla motor not spinning? Let's recap. For a long time I wanted to convert a fossil fuel car into a fully electric vehicle. The idea of bringing new life to an old car using modern technology really excited me. So I set out on a journey to make it happen. My plan: to use open inverter board and a Tesla motor as my electric drivetrain. I built the board using Damien Maguire design files which he has generously shared with the community. At the same time I was learning KiCad, I realized it would be useful to make an existing open inverter design and modify the PCB layout to suit my needs. While making only minor changes, I decided to integrate ESP32 module. To manufacture my custom board, I used JLC PCB. After some wait, I received new boards. I want to now try the first power-up sequence, which is really exciting, but at the same time it's a bit worrying. And I'll just clamp these to the 12 volts and ground. And now let's try power it on. Ta-da! An LED comes on, so you can see here. And that means that power is working. So LED is connected to 3.3 volts. And just to be sure, I want to actually measure the key voltages. On this board, the input voltage is 12 volts and we provide +5 and +3.3 to our PCB. I have done the measurements for those and all was good, with an expected range and stable. Now we know that power works. Before I solve the missing bit, I want to check if the main part of the board is working. In other words, I want to program the STM32 processor. So I'm now connected the programmer. All I need to do is plug it into the laptop. As this was a first programming effort on a new board, I expected problems. But to my total amazement, the whole process went smoothly, from doing bootloader and following up with the open inverter program. Everything worked. What a surprise. Unfortunately, JLC PCB has a limited inventory of parts, which meant I had to manually solve the missing components myself. This added an extra challenge to the process. This is where our video sponsor, PCBWay, comes in. What sets them apart is not only their exceptional PCB manufacturing quality, but also their comprehensive assembly service options. One standout feature for me is their turnkey solution, where they handle the entire process. They source components from reputable suppliers such as DigiKey, Farnell, Arrow and Mauser. When I order my boards from PCBWay, I don't have to worry about adding missing components myself. Thank you once again, PCBWay, for making this video possible. I moved on to finishing the board, carefully assembling and soldering remaining components. Now let's see if this actually works. To do that, I will need to program ESP32 module. What we will require for that is a SparkFun FTDI board that converts USB to UART. This is basically to allow the flow of the data. The second requirement would be to pull I/O pin low. To do that, I will need to connect the pin I/O to the ground. On the ESP module, this will enable programming mode. Once this is done, I will use Microsoft Visual Studio Code and Platform I/O to program. Now the connection is there, I loaded the code and entered programming mode. Let's go for it. And we have success. Programming is complete. Okay, let's go to Wi-Fi and see if this shows up in the list of available Wi-Fi modules. Connection is there. Let's connect. Connect, connection successful. Now let's launch the web interface. And we're up and running. Success. But when I started testing my new board, it did not work. Oh dear, it's not working. What have I done? How did I get myself into this mess? Well, I'm not gonna give up that easily. I'm gonna have to investigate. And to investigate, we will need to open the motor and do some measurements on the board itself. Let's get started. I opened up an inverter again, and this kind of became a routine for me. I can do it much quicker now than I did it first time. But this time I need to position the inverter very close to the motor part, so I can connect the shorter cables for all of the 3 phases of the motor. Well, at this point I want to solder on some of these tiny wires that will allow me to test the board safely. So first I want to solder accelerator, and this will be one of the PWM signal connections. Once the board was installed, I connected my oscilloscope probes, one to the throttle signal and another one to PWM signal. With the system powered on and probes connected, I can start measuring my signals. First I will do the throttle pedal. So the blue signal on the scope shows the throttle signal change, and when I press the throttle pedal it does increase. So the throttle signal is indeed getting registered. Next I check PWM signal, and as soon as I press forward switch I was getting the 1, but it wasn't changing in response to my throttle pedal. I had to analyze what did I do wrong. I found a few mistakes in my design. First, I had mistakenly swapped the connections for the current sensor 1 and 2. But after swapping them back over and running the test, PWM signal still wasn't changing. While reviewing the schematic, I observed that MC74HCT chip was driving the PWM. This chip acts as a level converter and passing data when the large enable pin is high. I realized I had mistakenly used MC74HC chip instead. The key difference is that HC variant accepts CMOS level inputs, while HCT variant accepts TTL level inputs. This means that HC operates from 2 to 6 volts, while HCT is designed for 4.5 to 5.5 volts. Given that STM32 processor utilizes TTL level outputs, I've replaced the HC chip with the correct HCT version, but it still did not work. Oh dear. At this point I decided to reflash the Open Inverter program onto the STM32 chip. And now what I'm going to do, I'm going to press start, and now the main contactor is on. And hooray, it worked. Seeing the motor finally respond as expected was an incredible relief. The combination of the Open Inverter board, my custom layout and ESP32 integration was working as planned. Alright, we're getting there. I'm so pleased and so relieved it's working. So if you want to follow up on my future videos, make sure you subscribe, make sure you like, share, and I will see you on the next one.